today's session.
Bandana, Priya and Vinita. Please
Alright, you guys record the session. Sorry, you guys just mute your systems. And if you have any questions, you can unmute and answer. Ask me the questions. Alright. So yesterday we discussed about these access modifiers and we...
I'm already...
Sorry? Hello?
Yes.
Yes, so what was that?
No, I was saying I'm already muted. They are saying that you
Alright,
should mute it.
fine. And you are muted and you are speaking as well, right? Alright. So these are the access modifiers what you can have in your applications to control the access of your members as well as classes. And we did see some examples for that. Person Java, yeah. So we did see how to use the public, private access modifiers in your classes. So as discussed, a class can have two access modifiers. One is public and one is default. If it is not public, it is default. It is package private. And if it is default, it will not be visible outside the package. Okay. At the member level, you have four access modifiers. Member, what is member by the way? Member is variable and method. Combinedly they are called as members. So these are the variables, these are the methods. So all these things are combinedly known as members. Members can have four access modifiers: public, private, protected and package private, which is default. We discussed about that as well. So about the visibility, understand this, that when it is public, it can be visible within the class, within the package, outside the class, and it is visible everywhere. When it is protected, it is visible within the class, within the package, outside the class but to subclasses. In fact outside the package but to only subclasses and not to the world. It is not visible to the whole world. I mean, it is not visible as a public scope. It is protected. No modifier, it is visible within the class and within the package only. And private, it is visible only within the class. So this is a kind of restrictive control what you can perform to your method members as well as your classes. So let's see what you can do actually with this with these access modifiers. So with these access modifiers, what you can enforce is you can enforce an important concept of object-oriented principles, which is encapsulation. Encapsulation actually means you can make your data secure by hiding the data and wrapping it using some methods. Right? Encapsulation is a technique of making the making the fields in your class as hidden and giving it restricted access. So what it says essentially is you have a data, you have a name here. It's your data, and in every application, data is very essential. It is crucial. You have to secure your data, and Java or any other object-oriented programming language means it provides more restrictions to access the data directly. So what we do in encapsulation is we make the data private. All right, we make the data private and hide the accessibility of this data. So let me show an example for this. In fact, I'll start using Eclipse from today just because it will be convenient if you start writing using Eclipse. I already have. Alright, so let me start the Eclipse bench. I'll create a project, a new Java project. If you want to see, if you are not very familiar of how to use Eclipse, just follow these steps. A Java project. I'll say oops demo. Finish it. Alright, so let me create a class, name it as fine. So in your applications, when you want to make your data private, you hide that. Imagine the requirement what I have now. Let's understand encapsulation with some real world examples. I will have a class called bank account. Alright, I'll have a class called bank account which will have some sensitive data. Obviously bank accounts have a lot of things which is sensitive. Alright, so in this I'll have some properties like private string name of the person who holds the account, private string account number, right, and private string balance. This is the balance what the customer carries. I mean it's his total balance in his account. And yeah, let's assume this is some information. When I make it private, these things will not be accessible outside the class. So let's assume this is the class which is my application, which is my main method, which is the application which I use to run the bank account. In this I can instantiate bank account PA equals to new bank account. Right. And if I try to access BA dot name and display that, it doesn't allow me. It is showing a red line over here. You cannot compile it. This prevents me. It will not allow because this is not accessible. The name is not accessible outside this class because it is private. And why did I do that? I just wanted to make the data secure. So no class can directly use that. I cannot use this name, or I cannot use account number, and I cannot use balance in my class which is outside this class in my main method. Alright, so how can you make use of these things? These are not allowed. So now to make them available, what I can do, I want to provide a restricted access. I don't want the other classes to view that, I mean directly, but I can give some methods to expose that outside the class. So for that purpose I can have methods like public string get name, and this method return name. So what am I doing in this method is I'm writing a method which will return the name field as the output. So whenever I call that method ba.get name, I'll get that name which is given here. Alright, Let's assume I will give the name some value here. For now I'll say person 1 or person 2. I'm giving some value. So if I display that, I can see the value. Let me run this application. There you see, it gives me the person value by using this get name method. Alright. So this is a read method. I can say that this is a method which is used to read my person, or it is called as getter method or accessor method. It is used to access your fields. They provide you access to the methods. Oh, sorry, the data. Now what is wrong in just seeing that if it is not able to modify? Yeah, that's good. If you just have to have a read only method, you can provide a get name. If you want to have a read only method, read only means you can just read it but you cannot write it. Outside the class you cannot change that, you cannot modify that. So that is the getter method. If I want to provide ability to even modify the method, I can say public void set name, and I'll say name, and in fact I have to take a set name will take a parameter called string name. It will take from the caller a string and it will use this to name equals to name, or I can say this dot name equals to name. So what I'm doing here is when I use this setter method, when this method is called, it will expect one string object to be passed as a parameter, and that string object will be passed to this dot name. And whenever I say this dot name, it refers to the current class object name. It refers to this. Sorry for that. So when I say this dot name, it refers to this name. So I'll remove this instantiation. I'll not initialize the value here, and I'll take the name from outside the class, public void set name, string name, this dot name. And when you call this method, I'll do it before I do this here, ba dot set name, you'll have to pass the name parameter. You'll have to pass the name saying, alright. So when this method is called, it will pass this string object to this method, and this method will take that and assign it to this dot name, and this dot name is the name of this bank account. So when you say now get name ba dot get name, you will actually see the name which is set here. Let me run this. There you see the name now, get name is printed because I'm calling ba dot get name and printing it. So I hope you are getting what I do here is ba dot set name takes a name object or a string object as a parameter. It passes that to the name field in your class and instantiates the value, initializes the value. And when you say ba dot get name, you get the values. This is similar to what we have done in our earlier examples about this one. Here you can say p.h, you are initializing directly by passing the value, but you cannot do that when it is private. You remember, if I make this as private, I wasn't able to say p dot name equals to some name. Alright, that's because it was public. I mean, it is not private. I can modify this. So similarly, I'll have to do the same thing to Now I'll not allow balance. I'll not allow the balance and account number to be modified outside the class. Right? So I'll not allow them to be modified outside the class. What I will do is I'll just have methods public string get account number and return this dot account number. I'm giving a method which is used to read that object. I think this is a getter method and setter or mutator method. Setter method or mutator method they are called as. Alright. This is also a setter method. Not right. This is a getter method. This is dot account number. And similarly I'll do that for public string. In fact, balance can be a float value or a double balance, and public double get balance return this dot balance. Now you can simply view that, but you cannot modify that. So if I want to view that, I'll say get account number, and if I want to view balance, get balance. Now when I run that, I'll get some default values. I did not initialize account number, I did not initialize balance. I'll initialize it here directly. Account number is, it's a string. Fine. And balance is some double value. So I'm initializing it with private data. Let me run this. Yeah, I get the values. Alright. Now when we go for some other examples, we will not have the data included in our private fields directly here, but we will have some mechanism to initialize the values at the runtime dynamically, because we don't expect that to every object. Fine. So I can say I'll just have some, I'll take data as 0, account number as 4500, some series it is. Let me run that. Yeah. Okay. So what this field is, it is a read only field, because you can only read it by using the accessor method, and this is also a read only field. And this is a read and write field. You can read this field as well as write this. How can you write it? By calling the set name. You can call the set name and pass any value to make the changes to the existing value. So this is what encapsulation is. Encapsulation refers to.
Why do you use?
Yes.
Why do you use this this keyword? Why did you use this keyword here in get
This keyword, yeah.
account number?
Yes, yes.
Yeah.
It's a good question. This keyword is always used to refer to the current class object. So in current class object reference, for example, BA is a reference to this bank account object outside this class, right? BA is a reference to bank account class, and I can use BA.setName, BA.getName, BA.account number. This is a reference to the object outside the class. But if you want to refer to the object inside the class itself, I want to refer to this object data inside the class. So this is used. This keyword is used for accessing members of your current class object. So when I say this dot name, it is referring to this name. When I say this dot account number, it is referring to this account number. And when I say this dot balance, it is referring to this balance. So this keyword is always used to refer to the current class object, and you can refer to the reason because the reason of this is, for example, let's take this example. I have this dot name referring to name field here, and I am getting a name object or a name string from outside this name. I have name and name, both are same, but how does the how does Java distinguish between these two things? It distinguishes between these two names with this keyword. This dot name refers to the name object, name field which is there in the class, and this name refers to the parameter which is coming from the method call. Alright. So does that answer your question?
Yeah.
Yeah, good. So this is encapsulation. Encapsulation is a technique for making the fields in a class as hidden and exposing some methods which can access your data. Now you have read-only fields, read-write fields in your classes to facilitate this kind of scenario, right? Now let us see an example of having array of objects, because we discussed about arrays and we discussed about objects. Now this is a logical point where we can actually understand what array of objects is ideally, and using that you can do you can manipulate multiple objects by using single instance reference. By using one reference you can access multiple objects. For example, now I can create an array of bank account objects. How do I initialize? Let me take another example, which is, alright, I'll take a new class in which I have bank account array demo. I have a main method, bank account array PA equals to new bank account array. Of 3 elements. Okay. Yeah. So I'm initializing this one. I have to initialize bank account, not the array demo. Fine. So I'm initializing this class which I have written here, bank account, to create an array of this class. I'm creating an array of bank account. I will have 3 bank account objects inside this array. Alright, so for now I have created the array, but I haven't initialized objects, and I haven't given any data to this array now. It is just an empty array which has default values. If you remember from earlier discussions when we discussed about arrays, what the default values of any object is. If in case of primitives, I told you that it is in case of primitive data type, it will, for integer it will take 0, for float it will take 0.0f, for boolean it will take false. Alright, the default values. And for objects For objects it will take null. So as long as I initialize the elements, those are simply they are null. Now I have to create objects and assign them. I have to say BA of 0, that is the first element, equals to new bank account. Alright, so I am creating one bank account, BA dot bank account object, and I assign it to the reference. Similarly, BA of 1 equals to new bank account object. Fine. BA of 2 equals to new bank account object. So now I have 3 objects initialized to this bank account array. This array has now 3 objects, and I am referring with BA0 index, BA1 index, BA2 index. Fine. Now I can get, in fact I can pass some setter fields. I can call the setter fields. I'll say BA of 0 dot set name. I'll give the name of the bank holder here, and for this example I'll say BA of 1 dot set name BA of 2 dot set name. Alright, I'm giving these 3 objects 3 names. Bank account objects are created. For now I don't have any values initialized to the data like account number and balance, so I will not give any values there because those are private fields. Now if I want to simply display what is there in this array, I want to display these objects and their names, I can do a collective operation and say for int I equals to 0, I less than BA of BA dot length, in fact BA dot length I plus plus. Alright, I'll say system.out.println BA of I dot get name. Similarly, I'll say get balance, and because those are read-only fields, I can say get account number and get balance. Alright, so let me run this example. I'll see the output. They receive one object, Ravi is created. He has a default account number 4500 and balance is 0.0. Ramu 4500, balance is 0. Now these values are common across all the objects because I have set them inside the example itself. If I don't provide these values, they will be null and 0. Right? Let me run this. They will be null and 0. So the account number is null and balance is 0.0 because I did not set any value. And it is a double. It will take 0.0 as the value for default. So if you understand that in an image format, you will have a clarity. This is your stack and this is your heap, Now what I did is I created one reference on your stack, which is B A, alright, and using this reference I can now access all your elements of the array. So on the heap side, what happened is it has created an array in which it has 3 objects. Alright, it has one object from here, another object from here. Alright, I hope it makes sense, and this array is referred by BA. Right. Now when I say BA of 0, it will refer to this object. When I say BA of 1, it will refer to this object. And when I say BA of 2, it will refer to this object. And when I say BA of I in this loop, I'm referring to all the objects. Now the values what I have given to every object, this is the name, alright, and this is the name for this object, account number, account name, and this is the name for the third object. Fine. And the other values like account number and balance, I did not initialize them in any of places, so they are default values, which is 0 and null for yes, this is 0, this is 0, it is 0 for Ramu as well, it is 0 for Ravi as well. Alright, so the instance variables which are not initialized are having the default values, but all these values are with every object. Every object has a copy of its own data. If you remember yesterday's discussion, I discussed about instance variables and said what instance variables are. Instance variables, those are in this example we have name, account number and balance. They are instance variables, and when you don't, in fact, instance variables are part of every object. Every object will have a copy of that data. I told that point. Fine. So this is how you can create and declare an account, any array to hold references. What did we do? We have bank account, 3 objects, initialize the objects and call the methods. You can call it by using reference. And we also have seen how to use a loop for accessing all the elements of this array. Alright. And one note about here is local variables and instance variables. There is a difference between how Java treats local variables and how it treats the instance variables. What are local variables? Variables which are local to a method level variables, they are called as local variables, and Java treats them differently when compared to the instance variables. Local variables which are not initialized, the compiler will complain if you try to use a local variable before initializing it. Whereas instance variables, you can even if you don't initialize it, Java provides a default value to that. It provides a default value and it is still usable. Alright, you can use the instance variables even if you don't initialize that, you will get a default value. What it says, that slide, what it says, let's assume I have a local variable here in it int b a equals to, I just declare it, I did not initialize it, right? And I'll say print a. Fine. So there you see the compiler is giving me an error here saying it is not initialized. So local variables have to be initialized before they are actually used. Whereas instance variables, even if they are not initialized, compiler will give some default values for these variables. This is not initialized, but we are still using it. This is not initialized, we are still using it. So this is the difference. Fine. So does it make sense? Now we have seen this example in which we have name, account number and balance, 3 fields. And for name I have a set method, a setter method, which can be used to call and set some values. But I don't have values, I don't have provision to initialize them outside the class. Now if I give any value to this object directly here, if I say some values, now this value will be for all the objects, right? If I give some values to the instance variables in the class itself, these values will be common to all the objects. So if I run this bank account now, array demo, I'll see this, that I have the values of account number and balance common for all the objects. Now it will not be possible that all the accounts will have same account number and same balance. So you will not definitely do God. You can see my screen? Yep. So you will not initialize these values in your objects directly because you don't want to have the same value for all the objects. You will not do that in your class. So there should be some provision for you to initialize these values. There should be some provision. For that purpose we have this constructor used. Alright, we'll see what constructors are. Constructors are, it's a special method. Constructor is a special method which is used to initialize the object, initialize the instance variables of the objects, and this method is called whenever you create any object. Once you create the object, this method is invoked, and this method can initialize. You don't have to call it. This is by default called by your virtual machine. When you create a new instance of a class using new keyword, a constructor for that class is called. Right? Whenever you create a new object of any class, you are calling the constructor. This constructor can be used to initialize the instance variables of the objects. If you don't define a constructor for a class, a default parameterless constructor is automatically created by the compiler. There is a constructor created by a compiler for you if you don't do it. So in our examples also we have a constructor. If you define any constructor for your class, no default constructor is automatically created. So understand these things, then we'll have one example as to how you can create a constructor. Constructor will have the same name of your class. Just look at this slide for a while. Let me go to the example and I'll define a constructor for this here, As the convention says that the constructor will have the name of the class, that is bank account, and it's a method, by the way, it's a method which has the name of the class itself. And here I will simply provide one print statement saying constructor called. Alright, that's it. I don't have to call it. Whenever I make the instance, whenever I say bank account equals to new bank account, I am actually calling this constructor. When I issue this command, I am calling the constructor. I'm actually calling the constructor. That's it. I'm calling it. That's it. That's all I have to do. So when I run it, there you see the constructor is called and the object is initialized and the data of this object is given. Alright. So every class will have a constructor. Every class will have a constructor. If you don't define a constructor, like in our earlier examples we have not defined any constructor. If you don't define any constructor, a default parameterless constructor is automatically created. So far in our examples we have not defined any constructor, but still there was a constructor created for everything. There was a constructor for person, there was a constructor for all the other examples what we have used earlier. So it's a Java, it's a syntax in which Java creates a constructor for you. But if you define any constructor in your class, no default constructor is automatically created. If you define it, it will not create a default constructor for you. It will use the constructor what you have defined in your example itself. Alright. So I hope that makes sense. So now the constructors can have parameters. Just like methods can have arguments and parameters, constructors can also have arguments. They can take some parameters. Alright. Constructors can have a parameter. So let's do that in our example now. I'll have the constructor. Now I want to enforce that whenever the bank account object is created, it has to have two parameters passed. One is account number, string account number, and the other is string balance. Right? Whenever the constructor is called, I want the constructor to have these two things. It will call the method, it will call the constructor and pass account number and pass balance. Right? So what will I do with that thing? I'll do an initialization of these private fields. They are private and I want to initialize them here. I'll say this dot account number equals to account number, right? And I'll say this dot balance equals to balance. Okay, this has to be a double, by the way, because here I have a double value. I need a double coming from the calling method. And when the constructor is called, when this constructor is called, it will have to pass these values. It will have to pass the account number. For every object, account number will vary. 45001323. Alright. And it will have to call the balance 0.0. I'll initialize the balance with some 0 in value. Okay, I'll say 0.0. So this constructor call will have these parameters passed, but let me give some value to it. I'll say 2000 bucks as the value. Fine. Run this. Yeah, run this. Proceed. There you see the constructor is called. Ravi is the name set. The name is set by the set method, and the account number is set by the constructor 4500123, and the balance is also set by this constructor 2000. So the default constructor what you have declared in your class or the parameterized constructor has these two parameters passed to the object, and accordingly the object is created. The object is created with these values. If I have another object, let me go to the array demo now. Let me go to the array demo, and there you see when I create the account objects, I now have to pass account numbers for these objects 4500231, and balance I'll say this person has 9,000 bucks. He's quite rich. All right, and he has the name set already. Second object, I'll say new bank account 4500232, and he has 6,000. And the third account, I'll say 4500234, and he has 1,000. He is kind of less fortunate person. Alright, now all the three objects have different bank account numbers and different balance. And when I run this, you can see Ravi has 4500231, 9,000 balance. Ramu has 4500232, 6,000 balance, and Kavi has 4500234 and 1,000 as the balance. And that's the essence. Here now the objects, you will not see 0 0 here, but you will have some values here. You have some balance for these three folks. Ramu has got, Ravi has got, he has got 6K. All right. Ramu has got 9K, and Kavi has got 1K. Fine, does it make sense? So this is the use of constructors. Constructors are used to initialize your objects, and you can have parameters passed to the constructor which will initialize the values. And the constructor parameters are used for initializing the instance variables of the class of every object. So I hope it makes sense. Let me get to this slide. In this example also we are doing the same thing. The account object constructor will take one int account number, string name, and double balance. Alright, it's a parameterized constructor. If you don't have any parameters passed, you will say it is a default constructor. And when you call the object, when you create the object, you call the constructor and pass three values here in this example. And in our example, we have seen we are passing two values. All right. So lastly, one point what I can specify here is the constructors can be overloaded. Constructors can be overloaded means you can have a constructor another constructor with a similar one, but let's assume this constructor will take another field called a string name as well. Another constructor, it will take string name, and what it will do with this name is it will say this dot name equals to name. So when this constructor is used, you will pass three values. You will pass the name, you will pass account number, you will pass balance. So when I am calling, let me call it over here, I am calling bank account BA2 is to new bank account. I'll pass three values. One is Hari, one is account number, it is a string again, 4500235, and balance I'll say 8,000. Alright, this is how I create a constructor. This is how I call the constructor which has three fields. Calling another constructor. Right, and I'll display these values again as usual. I'll say BA2 dot get name, BA2 dot get account number, BA2 dot get balance. Alright, I hope this makes sense. When I run this example, I'll see that this Ravi is called, this object is created by the first constructor, this constructor. Ravi set name, then get name, get account number and get balance. You get these values 4500123. Then Hari, I'm creating using the second constructor. I'm calling the second constructor, passing the name Hari, and 4500235 is his account number and balance is 8,000. So I'm calling this second constructor. So I can have more than one constructor to facilitate the use of the instance variables accordingly. Alright, so this is called as constructor overloading. I can have more than one constructor in my class, which allows me to initialize my class by more than one way. So I hope this makes sense. This is your whole example. Have a look at these examples. You can I'll share the recording once we are done with this now. So I hope this is a logical end for our session. This should be fine. We can continue from here in the next session. So I'll pause the recording, and if there is anyone having any question, you can ask me now.